Greetings, my name is Siddharth Bhardwaj, and in this technical demonstration video, I would like to present the final release of my System Health Reporting application. In this video, I would like to demonstrate transition state beta, where my Raspberry Pi and base station PC have already booted up, and as such, the Pi will send data about its health to the base station continuously, while the base station will listen and receive the data from the Pi about its health continuously. Then I'm going to demonstrate transition state omega, where I tell my Pi to reboot while my base station continues to listen. And as such, upon reboot, the Pi will automatically send the data about its health to the base station. Along with these two transition states, I would also like to demonstrate a error push notification feature, where I inject fault into my application through the means of a config file, and then demonstrate how the application sends a notification to the user who is monitoring the health of the microcontroller. Now, I would like to talk about the demonstration setup. So, on the left here, I have the Raspberry Pi into which I've SSH'd into, which is in ambulance A. On the right here, I have the base station PC, which will listen to the data that the Raspberry Pi will transmit about its health. And to the right of that, I have the database in which the system health data that gets transmitted by the Pi will get stored. And what you will see here as the data comes in into the spreadsheet, it should update the visuals automatically. And what's key here is the updating of the visuals on the website, which is a dashboard about the system health of ambulance A. So the URL for the website is available on the documentation site, but I have it bookmarked here. So I'm going to log in as the base station personnel. And what I'm concerned about in this application is the health of ambulance A. A quick aside, the visuals here on this website are generated using JavaScript, where on a refresh, I program my HTML page to refresh after a certain period of time, after which it executes JavaScript client-side and reads the spreadsheet. And upon reading the spreadsheet, it creates this visual real-time. And if you were following my technical demonstrations videos previously, you would notice that I've done a test about reliability of data propagation with respect to taking simply this embedded object, this visual, and then putting it onto a website versus using JavaScript to generate a graph real-time using Google Chart API. So that's enough about the setup. What I would like to show next is the gyroscope sensor. The gyroscope sensor is important because it simulates the operation of a BVM, a bag valve mask automated ventilator that would be operating inside of the ambulance. In essence, in my code of the Raspberry Pi, I have set X, Y, and Z threshold that model the angular velocity in the respective axes. And as such, I have used a config file with JSON format to set threshold values in these specific axes, and then program my Python code to either transmit a OK or an error based on the thresholds that I set. I will dive deeper into my code in a later section of the documentation, which you will find on the team website. However, in this case, I just want to demonstrate that the gyroscope is connected to the Pi and is operational at the moment. So as you see here, the Raspberry Pi is, the gyroscope sensor is continuing to transmit data about the x-axis, the y-axis, and then the acceleration in the respective axes along with the rotation value. Here's the code for it. As I said, I dive deeper into the code in a later section of the website and a different video. But in short, I've written a Python script that reads the data from the sensor, which would be connected to a BVM unit and then transmit the health of the system, which is connected to the the microcontroller, which would then transmit the data about its health. So now that that's aside, I would like to jump into the demonstration of transition state beta. How I would like to show this first is by telling my base station PC to listen. Now that that's listening, I'm going to then adjust my windows before I start sending the data from the Raspberry Pi inside the ambulance. So I want to first just demonstrate these two and the data coming in. So what you should see is the data being populated here. And so as you see, as data is sent from the Pi to the base station, it is received, and upon being received, it is then stored into a database onto the cloud, which then updates the visuals as you see here automatically. So just one more time, just gonna wait for one more transmission. Yep, perfect. You see 3 there, and then you see this also update. Though again, what's key is the update of the graphic on the website. So after 30 seconds, this website will update, and what you should see is the same amount of the same visual as you see there. Perfect. So that's updated, and as you see here, the last transmission was on 2000. Yeah, perfect. And you see the last transmission on 2000 for ambulance A on the website. That's publicly available. So now that the demonstration for transition state beta is finished, I would like to demonstrate transition state omega. What I'm going to do is I'm going to tell my uh, Pi to stop transmitting data about its health, and then I'm going to ask it to reboot. And what you should see is upon reboot, successful reboot, the data will start to propagate here, and my base station is continuing to listen. So upon reboot, it will then receive the data and then populate it in the web base into the database, which would then subsequently update the data being read by this dashboard. So I'm going to pause the video for a few seconds. All right, so as you see here, the um, the data is starting to come in. So I left my Pi as it was. My base station PC is continuing to listen, and as you see here, the records are starting to come in. Just going to show one more iteration. Perfect. And what that means is now the website should be updated as well. Just going to pull it up. So the last transmission was here. 02. I'm going to wait for just a few more seconds to update. Perfect. And you can see the updated visual on here as well. So that wraps up the demonstration for transition state omega. And now I want to jump into the demonstration of the push error notification feature. So what I'm going to do is as the data is continuing to come in, which you see here on the right, you can see that it will also be received here as an OK. What I'm going to do is I'm going to SSH back into my Pi and inject fault using the config file I showed earlier. And now that I'm in, I'm going to open up the config file. And I'm going to then change the value of this X threshold value. And now what you should see is you should see error popping in. And as errors is received, you should see a notification being sent to my email, which says what the error code is, the date and time for the error code, along with the ambulance ID. So that's why I received 2 error notifications, 2 errors, and as you see, I've received 2 notifications. Now, I do want to call out, since I'm using Amazon SNS, it requires a subscription. In this case, I'm being sent the notification. I could confirm it, and that would just take away this email. However, regardless of that, I still get the notification being pushed. Though I dive deeper into the code in a different section, I do want to show a bit about how the error gets sent and what it's being sent. Uh, so um, I am sending a error notification that has as I said, the message, the time and date for it, and the ambulance ID. And in this case, what you saw on the screen was an email that gets sent to me via Amazon SNS. I actually have a notification being sent to a cell phone, specifically my cell phone, though I'm unable to stream the screen of my cell phone real time at the moment. And so this is how the error notification gets sent programmatically through my code. Now, what I would like to demonstrate also is how I'm going to fix the error. The key thing to note here is the application is still running. The records are still coming in, as you see here, and and on the website, it's updating the website also, as you see here. And so if I want to fix this error, I'm not going to stop my application. I'm simply going to just adjust my file, config file, which is going to from which the changes are going to reflect in this application during runtime. So going back into the application and adjusting the negative to adding the negative back. And so what you should see now is you should see OK coming in. Yep, so you see the OK come in, and then confirm this on the website. Just gonna wait for it to update. Perfect. So as you see here, the most recent one was 2000 hours and 8 seconds, and you see the OK come in and you see the changes being reflected on the web application as well. In conclusion, I demonstrated transition state beta, transition state omega, and the error push notification feature for this application. I showed you how I was sent data from my Raspberry Pi and received data on my base station, which continues to listen, and then how the data gets stored inside of the database, and then how from the database using JavaScript I update or create a chart, a visual, analytics visual on a website. And this website is publicly available, and it can support multiple ambulances. In this case, we were working with ambulance A, but it can also support ambulance B. And that concludes the demonstration for this final release. Thank you for your time.